A few weeks ago, a new state-of-the-art text-to-speech model arrived on the scene, and it's called Kokoro or Kokoro. I don't know how it's actually pronounced because I think it's a Japanese word or maybe a Nigerian word. It's just weird. It sounds weird, honestly. But anyways, I did try it out, and it sounds amazing, like really amazing, honestly. Especially if you're actually comparing it to other larger text-to-speech models. It sounds amazing. So another cool thing is it's actually lightweight, which means it can actually run on edge devices or mid-tier PCs, or let's say just lower end devices, without actually taking ages to generate speech. That's something that's really important, which actually makes it a great option or a really good option for voice assistants that are not completely powered by audio to audio large language models or omni models like GPT-4o. So Kokoro or Kokoro TTS model has 82 million parameters, which is really small or minute, like really tiny compared to many other models. And it's surprising how good the speech it actually generates is. It's really surprising, honestly. So instead of just ranting about it or hyping it unnecessarily, let's just switch over to the IDE and set it up locally so you can actually judge for yourself. Maybe you would actually love it too. So over in our IDE, as you can see, we have main.py. That's where our main code is going to go over to. We're going to open up our terminal, but first of all, make sure you have your virtual environment already set up. It's actually recommended that you actually do that when you're starting a new project in Python. And we are going to run a couple of code. Now, they actually give us that here on their Hugging Face page. I'm going to be dropping the link to their Hugging Face page in this video description. So you can go over here and copy some of this. So the first one we're going to run this because we actually need this model. We need to actually pull these model files. You can just download them directly. The main thing you actually need voices and all these here, apart from readme.md and git attributes. You can ignore these two, but you need this and voices if you actually want to use different voices that they have available. So now if we go over here, as you can see, these are the voices that they actually have. They have this one AF, that's an American female voice, and they said it's a default voice and it's a 50-50 mix of Bella and Sarah. So they also have American male. AM is American male, AF is American female, BF is British female, and BM is British male. So that's just basically it. It's really simple to understand because if you go over here, you can see the language is determined by the first letter of the voice name. As you can see, A is American, B is British, which is really straightforward. And we are going to run this to code now. We're going to open our IDE again and we're going to paste in the code in our terminal. Now we're going to hit enter and it's going to start cloning it. To create this folder, kokoro82m, and let's wait for it to be done downloading. It should appear in our project directory. As you can see, voices is here. Now it's downloading the two models. Now if we go over to our browser again, let's go over to files and versions. As you can see, we have the .onnx and we have the .pth, that's PyTorch. We're going to first set up the one with the .pth, and then we're going to also set up the .onnx. We are going to compare the both of them, and at the end of this video, we're going to also compare this model to PyPyTTS because that's another fast model. Even though it's not as good as this model, it's really fast. So we're going to see how well it actually performs in that regard. We'll see which of them can actually perform inference faster. We're going to do that after we're done setting this up locally. Now let's go back to our IDE. So the moment the models are actually done downloading, we'll get on to copying and pasting the code that we actually need. So let's speed this up. So it's finally done cloning. Now let's open up the browser. As you can see, we have these two files here. That's what we actually need. Now let's open up our browser, go back to the model card, and let's copy a piece of this code. I'm going to paste it here. But before we actually run this, if you're actually using Linux, you have to actually run this code. But if you're not, you're going to have to use, if you're using something like a Mac, you have to use brew install espeak-ng. I think they actually dropped the link here for Mac users. You can go over to this link and you can follow your steps. It's really easy. Brew install espeak-ng, and we're going to use this. at the top of kokoro.py. Now, since we have this in our code, we can go over to this and we can paste this. So now, before we actually run this code, like I said, what we're gonna do is go over here and run this. We can actually do our pip install quietly. So as long as everything installs properly, we won't actually have any issues. So let's speed it up. Okay, everything seems to have actually run perfectly. So what I'm going to do next is here, I'm going to rename this. I'll just refactor and rename this to just call it this. So we can actually generate an audio file from this, because in the example here, this example is if you want to use Google Colab, and since I don't want to actually use it and I want to actually have the output file, I want the WAV file. I'm going to paste in a couple of code since I want to actually save the WAV file. Something else I'm going to also do is do this. So this is the function we're going to use to play the output or wave, the WAV file. This is what we're going to download, and we pass in the audio from this here. So that's all we're actually doing. You can send this to the top. So first sending everything to the top. Then we also add this here. So now we're actually pointing it to the correct directory. So we're pointing it to Kokoro and then voices and then the name of the voice. Something else to take note of is this is a voice name and we are picking the first one. That's why we actually use 0. Now, if you go over to the language here, as you can see the voice name, since this is a string, is going to take the first character, that is either A or B. Those are the only first characters available in all the elements inside this particular list, as you can see. So it's either A or B, just in case you don't want to do this and you want to maybe integrate it into your own personal stuff and you don't want to list all these voice name here, and or you want to just pick one voice and get on with it for your AI system, you can just use only A or B depending on the voice you're actually using. Since this is done, let's see, okay, we didn't actually import spy game. So now we have imported it and okay, everything seems normal. So now let's run this code and see. Okay, we're having this problem of model not found and it's happening here. So I'm going to add a dot here and also here, since this is also a file that's found here. So let's run it again and it should automatically play because we have this down here. We're passing in the file.
How could I know? It's an unanswerable question, like asking an unborn child if they'll lead a good life. They haven't even been born.
So as you can see, that is a loaded voice, the first one. Now we can actually change this. We can maybe use Bella. Let's hear how Bella sounds.
How could I know? It's an unanswerable question, like asking an unborn child if they'll lead a good life. They haven't even been born.
So as you can see, that's what we actually ran. Now I think there's a voice that's actually whisper, and I think let's check if it's Sarah. It's either Sarah or Nicole. Let's just play around with it and see.
How could I know? It's an unanswerable question, like asking an unborn child if they'll lead a good life. They haven't even been born.
Okay, let's check if it's Emma, and Emma is I think 5.
How could I know? It's an unanswerable question, like asking an unborn child if they'll lead a good life. They haven't even been born.
Okay, that's not the one, and that means it has to be Nicole.
How could I know? It's an unanswerable question, like asking an unborn child if they'll lead a good life. They haven't even been born.
As you can see, it sounds amazing. Now we can actually try out a male voice, and let's try George. Okay, I'm gonna change this to 7. It's a British male, so.
How could I know? It's an unanswerable question, like asking an unborn child if they'll lead a good life. They haven't even been born.
Now let's try an American male. We're gonna try Michael.
How could I know? It's an unanswerable question, like asking an unborn child if they'll lead a good life. They haven't even been born.
As you can actually hear, it actually sounds amazing. Now, what I'm going to do is I'm going to create a different file. I'm going to call it voice, and I'm going to create separate functions for the ONNX and also separate function for the PyTorch model. So we're going to run them off there, and I will also be adding I think I'm going to run PyTorch in a different project, but I'll still be calculating the time and we'll compare the time at the end of the day. So first of all, let's create that particular file and those particular functions. I think we're going to still use the voices. So we can keep this on here. Since I'm just running this on my PC, I don't plan on running this on any other machine. I don't need this check to check if we have CUDA here. So the next thing we're going to do is we're going to import something else from here. What we're going to be importing, we're going to import two functions, phonemize, and we're also going to import, let's see what the other one is. Tokenize. Those are the two functions we're going to be importing from this file. So let's go to voice and we're going to add phonemize and tokenize. So those are the two things we're going to be doing, and we're going to pass in the text. This is what we're going to be doing, and this is where we actually need to go. Now we're going to copy this. So another thing we're going to have to do is install this when the next runtime. While this is installing, let's copy this line. So instead of loading this like this, what I'm going to do is actually go to CPU, blah, 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 blah. Now we have to actually point this to the correct directory, that is this. So now in main.py, we can just get all this. What I'm going to do is import from voice. That's all we need. Now we can do this, and we can also, so now let's actually try this out.
Hello, how are you? I used PyTorch to generate this audio. Hello, how are you? I used nguyen's runtime to generate this audio.
As you can actually hear, it sounds amazing still. But the next thing we're going to do is calculate the time difference. We're going to add a time here at the end after it's actually done generating, after it's done calling this generate function, and we're going to add one at the top. We are going to calculate and print out the difference. We'll do the same thing for the ONNX model, and we'll see which of them actually runs faster. So that's what we're going to do. And after that, we're going to compare these to PyTorch. So now let's paste this in here. We're going to import time, and then we're also going to do this. So we are not actually including the part where it actually starts playing the audio, because that's not what we are actually measuring. Now let's run this code, and as you can see, we passed in the same text for both of them. For the PyTorch version, we passed in this text, and for the ONNX, we did pass in the same exact text. So we are going to run it now, and let's see how long they both actually take.
When you gaze long into an abyss, the abyss also gazes into you. Those who fight monsters should take care not to become monsters themselves. And if you look long enough into the distance of your ambitions, into that place where earth meets sky and possibility seems endless, you will find that the distance has also made its home in you, transforming you into something that those who never dared to look will never understand. When you gaze long into an abyss, the abyss also gazes into you. Those who fight monsters should take care not to become monsters themselves. And if you look long enough into the distance of your ambitions, into that place where earth meets sky and possibility seems endless, you will find that the distance has also made its home in you, transforming you into something that those who never dared to look will never understand.
That actually took a while. So I made a small change. I pushed this line of code up here. It was previously in Kokoro_NNX function, and it's actually required here. but I actually moved it up here because what I'm going to do next is really simple. So we can actually get a better reading of how fast it actually runs, how fast both of them actually runs separately. We're not going to measure them together. We're not going to do that anymore. We're going to go over to main.py, and since we're actually running the PyTorch model first, I'm going to comment this out, and I'm going to also take this off. Go over to voice.py, and I'm going to comment this out also. So we're going to be loading only the PyTorch model. Let's shrink this, and now we are commenting out the nguyen function. So we're going to run this first, and we're going to see how fast it actually runs. So let's run it.
When you gaze long into an abyss, the abyss also gazes into you. Those who fight monsters should take care not to become monsters themselves. And if you look long enough into the distance of your ambitions, into that place where earth meets sky and possibility seems endless, you will find that the distance has also made its home in you, transforming you into something that those who never dared to look will never understand.
Okay, the PyTorch model actually took 5.24 seconds. Now let's comment the PyTorch model.
When you gaze long into an abyss, the abyss also gazes into you. Those who fight monsters should take care not to become monsters themselves. And if you look long enough into the distance of your ambitions, into that place where earth meets sky and possibility seems endless, you will find that the distance has also made its home in you, transforming you into something that those who never dared to look will never understand.
So this is actually surprising. The PyTorch model actually runs faster than the ONNX model. But let's go over to PyPyTTS, and we're going to run it, and we're going to pass in the same text, and we're going to see which of them actually runs faster. Is it this particular text-to-speech model, or is it PyPyTTS? So I have it over here, and if we go over to this, as you can see, I'm starting from here and I'm actually printing it out here, which means I'm ending it here also. So I'm not actually measuring the play function as usual. So let's run the code. We're passing in the same text. So let's actually run it. And I made a mistake before. So let's...
When you gaze long into an abyss, the abyss also gazes into you. Those who fight monsters should take care not to become monsters themselves. And if you look long enough into the distance of your ambitions, into that place where earth meets sky and possibility seems endless, you will find that the distance has also made its home in you, transforming you into something that those who never dared to look will never understand.
As you can actually see, PyPyTTS actually runs faster than Kokoro TTS. As you can see, it takes 1.49 seconds compared to Kokoro that actually take over 5 seconds. Both the ONNX and the PyTorch version. I think it's because of the size of that particular model, because it's over 300 and something megabytes. If we go over to their webpage, let's go over to files, and as you can see, the files are over 300 and something megabytes. But if you take a look at PyPyTTS, the speaker models are lighter, way lighter. If you look at the voices, if we go over here, let's go over to English, British, let's go over to Corey, and go over to medium. As you can see, it's just 60 something megabytes for the medium. And if you go over to high, it's just 100 and something megabytes, which is really small. So that's just the basic difference. I think if it was actually smaller, it would actually take less time. And Kokoro TTS, I think this particular model sounds actually better. So I don't actually mind the size, especially if I want a really good AI assistant. I want it to actually sound less robotic, kind of, to sound more natural. And Kokoro TTS actually does that, since it's actually really lightweight, yet sounds really natural compared to PyPyTTS. PyPyTTS, it sounds robotic, but it's really fast and way more lightweight than Kokoro TTS. That's the only difference. But I do still prefer Kokoro TTS. And I've changed my text-to-speech model on my AI system to Kokoro TTS because I actually love the voices it actually has. The only downside is it's not actually multilingual compared to PyPyTTS. That's the only downside. Compared to many other text-to-speech models, it's not multilingual. But I think they are currently working on that, because if you go over to your community, if you scroll down, you're going to see train another language. I think they are working on something like that, and you can actually create a thread here and ask them how you can actually help if they actually need data sets or something. As for those of us that only speak English, we don't actually actually have a problem with this particular model. So it's really cool. And if you are someone that want to use it for other languages, then you can actually reach out to them. I'm going to drop the link to their Hugging Face page so you can maybe create a new discussion and do all that. But that's it for this video. Thank you for watching. If you did enjoy this video and you like what you see, make sure you do subscribe. Make sure you hit that like button. It's really important to tell YouTube that we're doing a good job so they can actually recommend this content to other people. And make sure you hit that bell icon so you get notified whenever I actually release a new video, which is also really important since we're on our way to our first 1,000 subscribers. That's our first milestone, and I've been ranting about this for the past how many months. Just help us out, click that subscribe button and the bell icon. And thank you for watching. Have a nice one.